Hey everyone, and welcome back to the channel. Before we jump in, if you're into all things tech and AI, do me a quick favor and hit that like and subscribe button down below. It really helps us out a ton. Okay, so we hear it all the time, right? AI is coming for our jobs, but what about the jobs we don't even see? The invisible ones. Today we're going to talk about a real unsung hero of the internet, the SQL Query Optimizer. This thing is the silent engine behind pretty much everything you do online. And the big question we're asking is, could AI actually do its job better?
So, before we can even get to the whole AI thing, we've got to understand the reigning champion. And you see, a query optimizer isn't just some random piece of code. Not at all. It's actually one of the most complex and, frankly, most intelligent components in any database. And its job? It's absolutely mission critical.
Okay, here's probably the best way to wrap your head around this. Think about your GPS, on your phone or in your car. When you type in a destination, it doesn't just give you a route, right? It calculates multiple options and gives you the best one, the fastest one, based on traffic, distance, all that stuff. Well, a query optimizer does the exact same thing, but for finding your data.
And the key word here is efficiency. When a developer writes a SQL query, they're essentially telling the database what data they want, but they're not telling it how to get it. That's the optimizer's job. It's the master strategist. It's the brains of the operation that finds the single best path to deliver that data, like instantly.
And believe me, this distinction makes all the difference in the world. I mean, any simple program could probably find the data, eventually, but the optimizer, it's built for speed. It's built for performance. It's the difference between walking to your destination versus hopping on a high-speed train.
So how does this strategic thinking actually work? It's a pretty fascinating three-step journey. First, there's query transformation. This is where the optimizer literally rewrites the developer's request. It's kind of like an editor polishing a sentence to make it clearer without actually changing the meaning. Next up is cost estimation. Here, it looks at every possible path to the data and calculates a cost, which is basically how much resource usage, like CPU and disk activity, it'll take. And finally, based on all those calculations, it generates the plan and chooses the one with the absolute lowest cost. Simple as that.
To really see the genius of this thing, let's look at a classic choice it has to make all the time. Do we use the brute force method, or do we take the smart shortcut?
Okay, so on one side, you've got the full table scan. This is the brute force approach. It's like being asked to find a specific word in a dictionary by starting on page 1 and reading every single entry until you find it. Yeah. On the other side, you have the index scan. This is the smart method. It uses an index, just like the index in the back of a book, to jump directly to the right page, the right section, the right row.
And this visual really just nails it, doesn't it? The full table scan is total chaos. All that wasted effort just to find one thing. But the index scan? That is pure elegance. It's precise, it's targeted, and it's incredibly efficient. The optimizer's entire purpose is to choose that smart path every single time.
Now, let's go back to that idea of cost. It's not about money. It's an abstract unit of measurement for how much work the database has to do, how many disk operations, how much CPU time. A lower cost means a faster, happier system. A higher cost, well, that means slowdowns and frustrated users.
And this right here is where you really see the stakes. This table shows what the optimizer is deciding. For the exact same data request, the inefficient path, that full table scan, comes in with a cost of 5,000. But the smart path, the index scan, it has a cost of just 5. The difference is absolutely staggering.
5,000. That's the cost of brute force. That's the cost of searching the entire library for one sentence. And that is what leads to those dreaded loading spinners on your screen.
And then there's this. 5. The cost of pure intelligence. We're talking 1,000 times more efficient. This is the result of the optimizer's perfect calculation, delivering the data you need almost instantly.
So, why does a cost of 5 versus 5,000 actually matter to you? Because it translates directly into real-world benefits. It's the difference between an app that feels instant and one that makes you stare at a loading bar. For businesses, it means saving real money on servers. And most importantly, it's what allows an app to scale from 10 users to 10 million without completely crashing.
So really, the traditional query optimizer is an incredible feat of engineering. It's a deterministic system. It takes in statistics about data, applies all these complex logical rules, and it calculates the most efficient path. It is a pinnacle of computational logic.
Which brings us all the way back to our original question. Can AI replace this? Maybe,
But the more profound question to leave you with is this. Can an AI, through machine learning, actually discover a more efficient path than this decades-old system of pure logic and calculation can figure out? Can learning beat calculation? That's the real frontier, and the answer to that is going to shape the future of how we all interact with data.